Hello guys, my name is Parth. Today I will be demonstrating cross-industry standard procedure for data mining on the bank marketing data set which I got from UCI Machine Learning. The goal of my data set is to predict whether a client will enroll for a term deposit or not. So the steps of CRISP DM, short for cross industry standard procedure, is the first step is business understanding, data preparation, modeling, and deployment. We will go by each of the steps in briefly in a while. So the first step is business understanding. As I said that for this data set, our aim is to predict that which model would be suitable to predict whether a client will enroll for a term deposit or not. Our data set consists of around 4,100 rows and 21 features, out of which one is our response variable, which is binary. There are 10 categorical features and 11 numeric features. So the next stage is data preparation. In data preparation, we will go through some steps to normalize our data if required, and we will be detecting some outliers which we may need to exclude from our data set or impute those with some different values. We'll be using dummy codes for categorical features, and as we go through our data preparation, we discover some features like past days. It is not distributed normally, and it is heavily skewed even after applying some transformations. So it is better to exclude such features from our data set. So as you can see in my data set, the summary of all the features. Over here we can see that there are some differences in the mean and median value, which signifies that there are possibly some outliers in this feature. So there are many other numeric features which have some differences in their mean and median, just like duration as well. So we will be detecting those outliers by using some functions, and we'll be using low factor function to detect the outliers, and the plot for our outliers is as such. This is the density of our outliers, and these are the points in our features which are outliers. They are denoted by the plus sign in red color. So as I had mentioned previously that there is a feature named p days which has many values which leads our data set, the feature, to skew significantly towards left. As we can see, even after applying some transformations like logarithmic or square root transformation, there is no significant difference in the statistical significance of the feature. So we will exclude this feature from our data set. The next step is that we will try to impute some values by replacing the unknown and non-existent cases in our features. So I have replaced the class levels like unknown and non-existent using the mice package. I've imputed them, and I have built a decision tree model for both the data sets, and we get the accuracy as follows. As we can see, the kappa statistic for our original model is about 0.60, and the one for the imputed data set is about 0.56. Hence, we conclude that we will be carrying on with our original data set, that is keeping the class levels as unknown and non-existent instead of imputing them. The next step is that we will be eliminating the feature as it has no statistical significance. We have also divided our data frame into numeric and categorical features for applying some transformations. We have normalized our data set using max min method. And for categorical features, we have used the package ADE4 and this function to create our dummy coded variables to see the correlation between our features in the data set. I have created again two correlation plots in order to visualize them clearly. So the first plot is for numeric features. As we can see here that there is no correlation between the response variable and the numeric features. But if we see here, there are some collinearities between our features, numeric features like employment variance rate and Euribor, and employment variance rate and the number of employees employed. We also tried to implement principal component analysis. As our dataset consists of categorical features, we are unable to perform principal component analysis on those variables, but we did principal component analysis on our numeric features. We can see the biplot. So we can see the biplot. We also created a new feature column for age where we divided age above 50 as senior citizen and below 50 as adult. We partitioned our dataset using caret package and create data partition function by keeping the ratio of partition as 75%. And moving forward to the modeling phase. So we first begin modeling with logistic regression model, and we select the features by AIC. So this is the function that does the work, and we get our prediction value for this model as the area under the curve for this model is 0.74, which is fairly good. We will move forward with other models and explore if we can get a better accuracy with other models. So our next model is neural network model, where we have implemented k-fold cross validation and hold-out sampling methods as well. The difference is in the train control method. For cross validation, we mention it as CV, and for hold-out sampling, this is the function. And so we get the predictions for both these models. The area under the curve for cross-validated model is 76%, and the area under the curve for hold-out sampling is 0.74. So we will select our cross-validated model as it performs better and it has greater accuracy as well. Our next model is SVM model. So as we see our SVM model, we have again used the train function, and we get an accuracy of about 91%, and the kappa statistic is fairly low. Hence, even this model is not performing that well as compared to our previous discoveries. So our next model is a rule learner model, and by far it has achieved greatest area under the curve. As you can see that I get area under the curve as 80%, which signifies that it is a good classifier. We have also implemented other models like KNN, regression model, and random forest model. By random forest, we get the AUC as about 71%. Sorry. As 71%, which is still not better compared to our rule learner model. We have also used stack ensemble models in order to see if different weak machine learning algorithms can perform better together. But the result was not quite as expected. We get an accuracy, we get a good accuracy, but the kappa statistic value is still fairly low for the stack ensemble models, as we can see here, it's just about 40%. Put that the rule learner has the best accuracy and a good capacitistic value as compared to the other ensemble models and other models which we had implemented. So the last step is deployment, where we provide a report to the client as in which model will be performing the best. And as we have concluded that the rule learner is the best model, and the learning outcomes and the summary of this process is that we have implemented different models for classification. We have also visualized using the histograms for feature selection, and also we have tuned and improved our model performance using the train function under caret package. And each task does give a different outcome for each classification task. So that is all. Thank you.